Good morning, students. This is Attagatla Nagaraju, lecturer in Electrical and Electronics Engineering, Government Polytechnic Station Network. On today's lesson, we will discuss about DEEE 5th semester's AC Motors subject. In that, we are discussing single phase commutator motors. Single phase commutator motors. So, in single phase commutator motors, universal motor, speed control, and applications of universal motor. Speed control and applications of universal motor we will discuss. Okay. So, in previous period, we have discussed speed control of AC series motor, reversal of rotation of AC series motor, characteristics of AC series motor, and applications of AC series motor. So, we have discussed the speed control of AC series motor. Construction of AC series motor look like same as DC series motor but some modification. Because DC series motor can't run on AC because in DC only dynamically induced EMF induced in the armature, but coming to the AC, along with dynamically induced EMF, transformer EMF, transformer EMF also present in the armature DC machine. Due to this transformer EMF, commutation is poor, hence sparking, and also AC losses are more. So due to that sparking, motor may damage. So DC series motor cannot run on the AC. Okay. So if you want to run DC series motor on AC, we have changed some modifications. Some modifications we have discussed, and also reversal of rotation of AC series motor, the changing field or armature. The characteristics of AC series motor similar to DC series motor, but somewhat lacks. And applications, we had seen some applications due to high starting torque. We can use wherever we need high starting torque. There we can use AC series motor. AC series motor. That's what we had discussed in the previous class. So, coming to the objectives of today's lesson. So, on completion of this period, you will be able to understand the constructional features and working principle of universal motor, types of universal motor, and also characteristics of universal motor, reversal of rotation of universal motor, we will discuss. And also on completion of this period, you would be able to understand the speed control methods of universal motor. Speed control methods of universal motor, applications of universal motor. Applications of universal motor we will discuss. Okay, coming to the introduction. So, universal motors. Universal motors are small capacity, small capacity series motors up to about half kilowatt. So, universal motors are small capacity series motors used about used up to about half kilowatts, which can be operated on DC or single phase AC supply of same voltage with similar characteristics. So can be operated. Universal motor can be operated on AC or DC. That's why it is called universal. So same voltage of AC or DC, we can get the similar characteristics. Similar characteristics. Okay. So coming to the constructional features. Constructional features of universal motor. The general construction of universal motor is similar to that of AC series motor. Construction of universal motor is similar to that of AC series motor. It has a stator, it has a rotor. Stator carries field flux, rotor carries armature conductors. So field and armature are connected in series. Okay. So general construction is similar to AC series motor. It has a commutator. It is also called commutator motor. Coming to the working principle, the working principle of universal motor is same as that of AC series motor. The working principle of universal motor is same as that of AC series motor. Coming to the types of universal motors. Coming to the types of universal motors. Generally, universal motors are manufactured in two types. Universal motors are manufactured in two types: non-compensated type, con- concentrated field, low power rating it has, and compensated distributed field, distributed field, high power rating. Power rating. So universal motors are manufactured in two types: non-compensated type and compensated type. So non-compensated type means concentrated field. It is used for low power rating. It is used for low power rating. Compensated type distributed field, and it has high power rating. High power rating. This is the universal motor, non-compensated type construction. So we can give AC or DC supply. So this is the field winding. This is also field winding. This is the armature connected in series. AC or DC we can give. So Non-compensated type has two poles. Non-compensated type has two poles having entire magnetic path is laminated. Having entire magnetic path is laminated. Compensated, non-compensated type has two poles having entire magnetic path is laminated. Armature is wound type similar to that of normal DC motor. Armature is wound type similar to the normal DC motor. Normal DC motor. Such non-compensated construction is shown in the figure. Non-compensated type construction is shown in the figure. Coming to the compensated type. Compensated type. In compensated type, the motor has distributed field winding consisting of main field and compensating winding. In compensated type, the motor has distributed field winding consist of main field and compensating winding. Main field and compensating winding. The construction is somewhat similar to the stator of split-phase single-phase induction motor type construction. The construction is somewhat similar to the stator of split-phase single-phase induction motor type. Single-phase induction motor type. It also has a wound armature similar to the normal DC motor. It also has a wound armature similar to the normal DC motor. Similar to the normal DC motor. So figure 2 shows the connection diagram for both the types of universal motors. One is non-compensated type, another one is the compensated type. So non-compensated type, so entire field winding is only at one place. But in compensated type, we have compensating winding and also field winding. So distributed field winding is there in compensated type. So we can use for high power rating, but non-compensated type only used for low power rating. Low power rating. These are the two types of universal motor: non-compensated type and also compensated type universal motor. So non-compensated type. The non-compensated motor is simple and less expensive than the compensated motor, but its operating characteristics are not as good as those of the compensated motor. So, non-compensated type motor, the non-compensated motor is simple and less expensive than the compensated motor, but its operating characteristics are not as good as those of the compensated motor. Compensated motor characteristics. The speed torque characteristics for both the types of universal motor are shown in the figure. Speed torque characteristics for both the types of universal motor. This is the non-compensated type. This is the compensated type. So speed torque characteristics. So compensated type has good speed torque characteristics. So compensated type universal motor has better speed torque characteristics. Compensated type universal motor has better speed torque characteristics. That is, the characteristics are same for the operation of motor on AC or DC supply. Compensated type universal motor has better speed torque characteristics. That is, the characteristics are same for the operation of motor on AC or DC supply. AC or DC supply. So, no load speeds of small universal motors may be much higher than their full load speed. No load speeds of small universal motor may be much higher than their full load speeds. Much higher than their full load speeds. Universal motors being high speed motors are smaller in torque, so smaller in size and lighter in weight as compared to other motors of the same output. So, no load speeds of small universal motors may be much higher than their full load speeds. Universal motors being high speed motors are smaller in size and lighter in weight as compared to other motors of the same output. Other motors of the same output. This is the universal motor. Gear trains for small universal motor. So full load speed of universal motor may be as high as 10,000 RPM when such high speeds are not required. Gear trains are used to reduce the speed. Gear trains are used to reduce the speed. Reduce the speed. This is the universal motor. So here is the motor frame. These are the field coils. This is the carbon brush. This is the spring to press the carbon brush to the commutator. These are the brush holders. Okay, this is the motor shaft. There is the cooling fan. This is the commutator. This is the carbon brush. These are the field coils. This is the motor frame. Motor frame. So universal motors are easily recognized because they use a commutator and brushes. They use commutator and brushes. Universal motors are easily recognized because they use a commutator and brushes. Coming to the reversal of rotation. Reversal of rotation. The direction of rotation can be reversed. The direction of rotation can be reversed by reversing the flow of current, reversing the flow of current through either the armature or field winding, but not through both. So, by to reverse the rotation of the motor, we can reverse the flow of current either by armature or field, either by armature or field, but not both. The usual method is to interchange the loads on the brush holders, to interchange the leads on the brush holders. Coming to the speed control techniques, universal motors are small capacity series motors. Small capacity series motors up to about half kilowatt, up to about half kilowatt, which can be operated on DC or single phase AC supply of same voltage with similar characteristics. Same voltage with similar characteristics. The following methods are used for speed control purpose. First one is the resistance method, next tapped field method, and governor method, read governor method. So the following methods are used for speed control purpose: the resistance method, tapped field method, and governor method. Three methods. So the resistance method of speed control of universal motor. So here we can use a variable resistance in series with the field and armature. The resistance method of speed control of universal resistance method of speed control of universal motor. By varying the resistance R connected in series with the motor, the speed can be varied. By varying the resistance or connected in series with the motor, The speed can be varied. It is used for screening machines. The variation of resistance is affected by means of a foot pedal. By varying the resistance are connected in series with the motor, the speed can be varied. The speed can be varied. It is used for queuing machines. The variation of resistance is affected by means of a foot pedal. A foot pedal. Next method is the tapped field method. Tapped field method. Here, this is the low, medium, high. Three tappings are there. This is the field board. By by using a tapped field, thereby reducing the flux and hence rising the speed. Rising the speed. For this purpose, either of the following arrangement may be used. The field pole is wound in various sections with wires of different sizes and taps are taken out from each section. The field pole is wound in various sections with wires of different sizes and taps are taken out from each section. Nichrome resistance wire is wound over single field pole and taps are brought out from this wire. Nichrome resistance wire is wound over single field pole and taps are brought out from this wire. This is the governor mechanism resistance, capacitance and a switch. Universal motors, particularly these used for home food and drink mixers, have a number of speeds. Section of speed is made by centrifugal devices. Centrifugal devices governor located inside motor and connected as shown in the figure. Universal motor, particularly these are used for home food and drink mixers, have a number of speeds. Have a number of speeds. Selection of speed is made by centrifugal device. Centrifugal device, that is governor, located inside the motor and connected as shown in the figure. The switch is adjustable. Switch is adjustable by means of an external lever. By means of an external lever. If the motor speeds rises above that set by the lever, the centrifugal device opens two contacts and inserts resistance R in the circuit to reduce the current and so reduce the speed. The switch is adjustable by means of an external lever. If the motor speed rises above that set by the lever, the centrifugal device opens two contacts. Centrifugal device opens two contacts and and inserts resistance R in the circuit to reduce the in circuit to reduce the current and so reduce the speed current and so reduce the speed. When the motor runs slow, the two contacts close and short circuit the resistance so that the motor speed increases. When the motor runs slow, the two contacts close and short circuit the resistance so that the motor speed increases. This process is re- repeated so rapidly that variation in speed are not noticeable. A capacitor C is used to reduce the sparking produced due to the opening and closing of governor contacts. Opening and closing of governor contacts. So coming to the applications, the more common applications of universal motors are the following: vacuum cleaners, electric shavers, portable drills, mixers. The more common applications of universal motors are vacuum cleaners, electric shavers, portable drinks, mixers, screwing machines, small grinders, screwing machines, small grinder, wood shapers, saws, rotors, calculating machines, etc. Okay. And so we will see stepper motor in next class. Okay. We will see stepper motors in next class. So we will conclude today's section. Coming to the summary, coming to the summary, universal motors are small capacity. Universal motors are small capacity, less than half kilowatt series motors. It can be used for DC as well as AC supply. So, universal motors can be used for DC as well as AC supply, single phase AC supply. The non-compensated motor is simple simple and less expensive than compensated motor. So non-compensated motor is a simple and less expensive than compensated motor. But the characteristics are not as per the compensated type motor. So in non-compensated type motor only concentrated field, single field is there, is used for low power ratings, low power rating. But in compensated, we can use compensated winding. So distributed field is there. It is used for high power ratings. Compensated type universal motor has better speed torque characteristics. Compensated type universal motor has better speed torque characteristics. Better speed torque characteristics compared to non-compensated type non-compensated type motors. So universal motors universal motors being high speed being high speed motors are smaller in size and lighter in weight as compared to other motors of the same output. Universal motors being high-speed motors are smaller in size and lighter in weight as compared to other motors of the same output. Same output. The direction of rotation can be reversed by either reversing the flow of current either reversing the flow of current through either armature or armature or field winding. Okay, both but not both. So we have discussed in this period about speed control methods of universal motor. Speed control methods of universal motors. Three types of speed control methods we had discussed. And applications of universal motor. High speed universal motor. It has home application, vacuum cleaner, electric shavers, small rating grinders, food processing, drinking, variable speed, universal motors. We can find the applications at home. Coming to the quiz, universal motor works on DC supply. Yes, it can work. Option B, AC supply, single phase AC supply. Yes, it can. Option C, DC or single phase AC supply. Yes, DC or single phase AC supply. Option D, none of these. So universal motor can work DC or single phase AC supply. It can be run on both DC and single phase AC supply. So option C is the correct answer. Option C is the correct answer. Okay. Next. Compensated type compensated type universal motor having having option A better speed torque characteristics. Option B no load speed may be much higher than full load speed. Option C both A and B. Option D none of this. So compensated type universal motor having better speed torque characteristics? Yes. Compensated type has better speed torque characteristics. So, compensated type universal motor is having better speed torque characteristics. Yes. No load speed may be no load speed may be much higher than full load speed. Yes. Option C. Both A and B. Option D. None of these. Compensated type universal motor is having better speed characteristics. No load speed may be much higher than full load speed. Yes, options both A and B. Answer both A and B. Better speed characteristics. Speed characteristics. No load speed may be much higher than full load speed. Much higher than full load speed. In electric sewing machine, the following motor is preferably used. Electric sewing machines. DC shunt motor, AC capacitor start motor, universal motor, AC split phase motor. So, universal motor. Universal motor is the correct answer. So, coming to the frequently asked questions, what is universal motor? What is universal motor? Explain the construction and working of universal motor. Explain the construction and working of universal motor. Next. How the direction of rotation of universal motor can be reversed. Direction of rotation of universal motor can be reversed. So what is universal motor? Universal motor may be run. It can be run on either on AC or DC. Construction is similar to the AC single phase AC series motor we have discussed in yesterday's class. We can change the direction by either field or armature. State the various methods of speed control of universal motor. We have seen three types of methods: speed governors, variable resistance, taper speed. Mention the applications of universal motor. Universal motor has more applications in home, vacuum cleaners, sewing machines, small grinders, mixers, food processing, etc. Okay, thank you. So, if you have any doubts regarding this class, you can mail me or you can contact me at 9866930004. Okay, you can contact me through WhatsApp also with the same number. Thank you.